Good morning, class. Today we're going to have a brief overview about friction. Let's get started. So, all about friction. Friction is a force that resists an object's current velocity. And friction will also attempt to resist any attempts from motions that are starting from rest. What this is these two statements here are really about direction. So if we keep this in mind, we always know which direction is the friction going to go, because if it's moving, it's going in the opposite direction it's moving. Or if it's currently at rest, if somebody's trying to move it, friction is going to try to stop that. So friction will always resist the direction of motion or the attempt to start motion, right? So that's what those statements are about. Now, friction, it is calculated with a formula that we've covered before. The force of friction is equal to mu is known as our coefficient of friction, multiplied by the normal force. And if you need any refreshers on the normal force, please check the last video as we covered normal force with some detail. Now that mu, the coefficient of friction, is a measure of how bumpy or how smooth. When mu is big, the force of friction is big. And the reverse is also true, right? So you could say when mu is small, the force of friction is small. So this first example has a block that is freely sliding across level ground. What does that mean? Well, level ground means that it is flat, a flat ground, and that there are 3 kilogram block is freely sliding. In other words, nobody is pushing it. Now, there are still forces acting on it, even though it is freely sliding. One, this ground is on Earth, so there's got to be a little bit of gravity, right? The force of gravity. And we, in fact, know the size of the force of gravity. It's 3 times 9.8. 29.4. There's also, because it's on the ground, a normal force. And we did say that there is a coefficient of friction between the block and the ground. So that means there's a force of friction. So I'm going to write in this force of friction here. Now, when I read this problem, there's some other information that's going to be very important. It's the fact that it is slowing down at a rate of 2.2 meters per second squared. So what direction is that acceleration? Well, if you're thinking about this, would this box be moving up or down, or would it be moving left or right? It's definitely a horizontal or a left and right motion. So our acceleration is actually going to be slowing down, going that way at 2.2 meters per second squared. That's going to be really helpful because when we make a net force equation, we know that we get to include all the forces that are in that same plane of motion, or that are parallel to left and right. In other words, the force of friction is parallel. Is normal force of gravity parallel to that? No, they are not. So now let's break things down into what we know. Well, I know the net force can be written as mass times acceleration. And if I read what this problem was asking for correctly, I want to know the coefficient of friction. My force of friction formula actually turns into the coefficient of friction multiplied by the normal force. Let's take a look. Let's write in all the things that we know. Do we know the mass? Yes, it's a 3 kilogram object. Do we know the acceleration? Yes, the acceleration was 2.2 meters per second squared. I'm trying to find the coefficient of friction, so that makes sense that it's still a variable. But do I know the normal force? Well, it wasn't given in the problem, so I'm going to have to find it using the same techniques that we used in yesterday's video about normal force. Let's take a look. Looking at the situation in the up-down direction, in this up-down direction here, I see that these will be balanced because the box isn't moving up or down. So that means my normal force has to balance gravity in this particular situation. In this particular situation, my normal force is 29.4. So I can write that in here. All right. Now it's time to bring out our calculator again and finish this up. 3 times 2.2 was 6.6. And here's our coefficient times 29.4. I can divide both sides by 29.4. And that will get me my coefficient of friction. 0.22. The coefficient of friction between the box and the ground is 0.22. Let's look at our next problem. Joe is descending in a rock chimney. That's a crack in a cliff that has two close walls. He has 430 newtons of normal force exerted from each wall, each with a coefficient of friction of 0.77. How fast will Joe accelerate if he has a mass of 70 kilograms? Well, this one's going to take a little more work. Let's draw it out. Here is our rock chimney. It has two walls, and Joe is in between them. Now, if I looked what's happening with Joe, Joe has 430 newtons of normal force from wall 1, and he has 430 newtons of normal force from wall 2. But all of our rock climbing occurs on Earth, so he also has a force of gravity. Now, what's going to make Joe resist falling down and hurting himself? Well, it'd be the fact that there's friction. There's some friction from wall 1, and friction is going to try to slow him down. So we have force of friction from wall 1, but he's also touching wall 2. So here's force of friction from wall 2. So this is an interesting situation. Joe actually has two forces of friction, one from each wall that he's in contact with. And as we can see, they're slowing him down in the fall. In other words, they're resisting gravity because gravity is trying to pull him downward. We can see how this will help us find, hopefully we can see how this will help us find Joe's acceleration. To find acceleration, we always have to use net force. So the net force here equals, now winners or losers, I don't necessarily know. I'm just going to say down will be my positive or my winning direction, and I'm going to say up is my losing direction. Force friction 1 is resisting, and force friction 2 is resisting. Now I'm not going to write in my normal force for either 1 nor 2, because to do that, they would have to be going in the same parallel direction as the force of gravity, which is up and down. The normal forces are left and right. They're perpendicular. They don't go into the net force equation. Now, I don't know any of these numbers, but we can take some time to figure it out. This force of gravity is going to be 70 times 9.8. So that's 686. 686 newtons. If I want to know, well, how big is force of friction 1? Force of friction 1 is the coefficient times the normal force. In fact, the normal force of 1, because it's in contact with wall 1. That coefficient was 0.77 times that, 430 newtons. So that's going to be 331.1 newtons. 331.1 newtons. Force of friction 2 is going to be the coefficient times normal force 2. And the second wall has the exact same coefficient in this scenario, as well as having the same normal force. This means you punch in the same numbers into your calculator, you're going to get the same number result. Well, that's going to make our lives a whole lot easier because we know net force can break it to mass times acceleration. That mass is 70 multiplied by the acceleration equals our force of gravity, 686, minus force of friction 1, 331.1, minus force of friction 2, 331.1. All we got now is a little bit of calculator work, so let's wrap this up. $23.8 newtons total left over. And to find that acceleration, I see that it's being multiplied by 70, so I'll divide both sides by 70. You find here that the acceleration will be equal to, let's punch it into our calculator, 0.34. 0.34 meters per second squared, and it's in the positive direction. I designated gravity as positive, so this direction is downward. So in this situation, Joe will continue to descend downward and actually speed up as he's going downwards. All right, class, I hope that was helpful. Have a good day.